Hi, my name is Jake Bramer. I'm the Prototype Lab Supervisor here at the Tech Center. Our goal as Prototype Labs is to provide the product development teams with some early prototypes, jigs, fixtures, other outside-the-box solutions. We're essentially the makers of the Tech Center. If there's a concept that you have or a design that you want to physically get in front of you, we're likely the department that you're going to interface with. In industrial manufacturing, there are two high-level approaches to accomplish this, and we employ both methods here. The more conventional approach, the first approach, is your cutting, your welding, machining. Those are your traditional manufacturing processes. We have multiple different machinery, pieces of machinery here on site that fall into that category, including a plasma table, several manual and computer-controlled mills and lathes, as well as a full weld shop that employs multiple different weld technologies. We also have multiple hydraulic and manual presses, as well as a variety of shears, so that we can do different forming and cutting operations. And then of course the essentials such as the drill press, the saws, as well as hand tools, pretty much every hand tool that you can imagine. Really a large percentage of all the yellow and blue fixtures that you might see around the facility are actually made by us. We also have several high precision pieces of inspection equipment, including a state-of-the-art 7-axis probe and laser scanning arm, capable of measuring or reverse engineering down to the thousandths of an inch within a 13-foot circle. That's the capability to pinpoint and measure something with the accuracy of about 2 white blood cells, all within the area of your neighbor's trampoline. The second high-level approach is through additive manufacturing, rapid prototyping, or what's more commonly known as 3D printing. It's generally referred to as rapid prototyping because we're able to shrink the standard timelines for physical prototypes from weeks or even months down to a matter of hours or days. The first, most tried and true method of the industry is fused deposition modeling, or FDM. These two machines are essentially computer-controlled, large format hot glue guns. Spools of a selection of engineering plastics are fed into high precision, heated nozzles to extrude material layer by layer into the desired shape. Within a build chamber about the size of a large mini fridge, we can print with a layer height of about 7/1000ths of an inch or 2 sheets of paper. As our largest machine, we are able to build high fidelity, full-scale truck components to enable early design validation, preliminary aerodynamic testing, accelerated ergonomic evaluations, and more, frequently involving highly complex geometries not easily achievable through more traditional means of manufacturing. The second method is what's referred to as PolyJet technology, and this is able to print at a scale of thousandths of an inch, or about half the thickness of a human skin cell. This build chamber on this machine is about the size of a small microwave. This machine is essentially a 3-dimensional inkjet printer, spraying tiny droplets of a selected combination of proprietary ultraviolet light-cured materials. This combination of materials allows us to print in over 360,000 different colors, as well as printing in high clarity, clear or translucent materials, flexible materials, simulated rubber materials, or any combination of those materials. PolyJet technology is well suited for small component prototypes that need a high level of photo and tactile realism, such as interior switches, shifter knobs, steering wheels, and other components focused on styling and driver or passenger comfort. The speed of these plastic machines allows for rapid computer model to parts in hand refinement of the design in a matter of hours, and greatly reduces lead times for product development processes. Lastly, we also run what could be referred to as a metal powder-fed laser welder, or what's referred to in the industry as direct energy deposition, or DED. Using metal powder of any composition that can be sourced and welded, a 2,000 watt terbium laser is fired down the center of the powder stream with an 100% argon purged build chamber to form the desired print. This machine is actually a hybrid machine in that it uses both additive technology, or 3D printing, and subtractive technology, machining. It is first and foremost a 5-axis computer-controlled milling machine and can be used as 100% mill, 100% metal 3D printer, or a combination of the two. We're continuing to find new ways to employ this technology, but are currently investigating printing testable engine components for weight savings, fuel economy, and increased power and performance. This machine excels with exotic materials such as Inconel and titanium, and those can be extremely difficult or expensive to machine using traditional manufacturing methods. All of these tools, coupled with the wealth of experience of our Prototype Labs crew, allows us to make just about anything that you can dream up, and all within the four walls of the PACCAR Technical Center.